Compilers and interpreters are both tools used in the process of translating high-level programming languages into machine code or an intermediate form that can be executed by a computer. However, they differ in their approach to this translation and in how they execute programs. Let's delve deeper into the differences between compilers and interpreters. Compiler translates the entire source code into machine code or an intermediate code before execution. The result is a standalone executable file. Interpreter translates and executes the source code line by line without creating a standalone executable. The translation happens at runtime. Compiler generates an executable file and the user runs this file directly. The compilation phase is separate from the execution phase. Interpreter reads the source code and executes it directly, translating each line just before it is executed. There's no separate compilation step. Compiler. In some cases, compilers generate an intermediate code, like bytecode, during compilation, which is then executed by a separate runtime environment. Interpreter. Some interpreters directly execute the source code without creating an intermediate representation. Compiler generally produces more efficient code since the entire program is optimized before execution. However, the initial compilation might take longer. Interpreter provides quicker feedback as it translates and executes code line by line. However, this approach may lead to less optimized code overall. Compiler debugging is often done with the help of debugging tools after the compilation phase. It might be challenging to associate errors with specific lines in the original source code. Interpreter allows for easier debugging as errors are reported in the context of the original source code. Debugging tools can be integrated into the interpreter. Compiler generally results in lower memory usage during execution since the entire program is translated before running. Interpreter may have higher memory usage since it needs to keep track of the program state and interpret code on the fly. Compiled languages. In compiled languages like C, C++, Java, Go, Rust, Swift, and Net languages, the code you write is transformed into a form that the computer can directly understand before running. It's like preparing a detailed set of instructions in advance. Interpreted languages. In interpreted languages such as Python, JavaScript, Ruby, and PHP, the code is executed line by line, directly translating your instructions into actions without a separate preparation step. Some languages might use a mix of both methods for flexibility. It's like giving instructions on the fly. In summary, compilers and interpreters represent different approaches to language translation and program execution, each with its advantages and trade-offs. The choice between them depends on factors like performance requirements, ease of debugging, and the specific characteristics of the programming language. Thanks for taking the time to watch this video. We hope you now have a better understanding of the differences between compilers and interpreters and how they influence the performance, debugging process, and memory usage of programming languages. If you found this content useful and informative, please give it a thumbs up. Share it with your friends, colleagues, or anyone you think might benefit from this information. Don't forget to subscribe to our channel for more insightful content on programming and other tech-related topics. Your support helps us continue producing high-quality educational content. Stay tuned for more, and happy coding!